Hello everyone, my name is Brian Kraft with Spentys, and I'm joined by Sagar Shetty of Bionic Prosthetics and Orthotics. And today we are going to go into Bionic Prosthetics and Orthotics integration of digital into their clinics. And let's just get right started. Tell me how Bionic got started with digital.
Well, Bionic's journey into the digital workflow started about 6 or 7 years ago when we bought our first 3D printer. It was the talk of the town, 3D printing in ONP, and everybody was wanting to do something about it. The knowledge around that, on how that really works, was very limited. But knowing us, wanting to adopt the latest and the greatest out there, immediately jumped in. We bought a 3D printer, and then in the next 2 or 3 years, we printed maybe 2 prosthetic sockets. With that printer, we had a very long learning curve, let's just say, because we jumped into the idea not knowing much about how it works. We just wanted to adapt 3D printing in our practice, and of course, now we are at a different stage. We use 3D printing very routinely at our clinics, 3D scanning and 3D printing. And even in terms of technology, I think, a lot has changed from where it was 6-7 years ago to what's available now. This is really an exciting time in ONP to embrace digital technology, because you have a lot of tools available at your disposal and a lot of resources to make that transition into the digital workflow in ONP feasible and really easy today. So you won't have to go through that big learning curve that we had to. So that's kind of where our journey started, and of course we'll talk more in detail about what we do now and what we have learned through that process.
7 years.
Yes.
Digital technology, that's, it could be overwhelming if you want it to be.
Right.
And maybe 7 years ago, if you only did 2-3 sockets in 2-3 years, it may have been a little overwhelming.
Correct.
But I think that today, and our conversation today, we'll see how some of the technology has evolved and, like you said, has become a lot easier to integrate.
Right.
Today I also want to talk about some of the actual printers that you had in the beginning,
Sure.
how the technology has, within your specific clinics, evolved. Where did you get started, and what printer are you using now? And I think that's a good way to start. So
Sure.
that first printer.
Sure. Well, we started out with a small desktop printer, and played with it, and really struggled with just the first layer printing. When you're talking about printers, desktop printers, they usually use FDM technology, and there are all these different type of 3D printing technologies available, but the one that we jumped into was FDM, because that was the fastest, easiest, most economical option to jump into. And really, there was very limited knowledge available on the materials. What material would you print with? What temperature will something print at? What speed it should print at? For a successful print, what material sticks to the print bed when you first start printing? Just to get the first layer of the print to stick on the bed was like this major hurdle that we had to, pass through. But even before we reached that point, how do you design something that you can print? Traditionally, how things have worked in the ONP world is patient comes in, you do an evaluation, you want to make a custom device, you take a plastic cast of the patient's limb, and then you convert the plastic cast into a plaster model, and then you hand modify that plaster model, and then you fabricate the device over that positive model using plastics and resin and carbon fiber, whether you laminate it or you drape form it. But if you have to print something, well, you have to design something digitally. And I think that was another big challenge because, you know, O&P practitioners went to school to become an O&P practitioner and not, you know, an engineer, and there was very limited knowledge about CAD/CAM, so to say, as a technology, and really, you know, advice to a lot of people who are wanting to implement 3D technology is understand all of the areas that that you need to know about, you know, with 3D printing. Just having a 3D printer at your clinic is not a solution. You need to be able to design something to print it. So, you know, having limited knowledge about that also made things harder, because if you need to print something, well, you need to design something first, and you know, that's something. Again, you know, today we have a lot of options available for people that can make it a lot easier.
A ton.
Yes. So, you know, we really had to, you know, put a lot of time into, you know, learning some software to do the clinical modification and to do the design. You know, we used multiple different softwares, and then to be able to slice it and kind of prepare it for printing. Had, you know, went and took some 3D printing courses.
You did?
I did.
From where?
I went to Rick Sevier at Steampunk Bionics. He runs a week-long 3D printing course. So I went and learned everything that I could from him about, you know, using some of these software tools. And that's when we really got more engaged, because now we knew, okay, now we know how to design stuff, and now we can print it. You know, by that time, I think technology with printers also improved. Scanning technology improved. Our first scanners were these, we still use those, the white light scanners that you have to have a big setup. You know, you have the laptop and you have the scanner and you have all these wires, and you know, when patients come in, it can be overwhelming for the practitioner and the patient as well to, you know, do the whole setup. But you know, and those were expensive scanners. Of course, you know, in terms of the resolution, you can get a great scan, but you know, they were expensive and they were cumbersome. But you know, now technology has reached a point where you can have an app on your phone, and you can, you know, take a scan with just, you pull your phone out of your pocket and you just take a scan, and you have pretty good accuracy with those scans. And you know, we have the structure scanners that you can use with the iPad. So you have a lot of scanning options. I think that's the first step in the digital workflow. How do you get an impression? How do you get the measurements first digitally? And you know, we have the white light scanners, we have the, you know, structure scanners, and we have the apps on the phones that you can scan with now. And once you get those scans, the first thing you need to do is, you know, clinically do the modifications, whether that's, you know, correcting any deformities, or you know, you're doing volumetric reductions, or you know, adding relief to, you know, areas that are pressure sensitive and stuff like that, that you typically do on a plaster model. And you need to be able to do that on a digital model now. And again, there are a lot of different softwares that are available. You know, we use the Omega software from Willowwood. You can do a lot of those on Mesh Mixer and a lot of other, you know, CAD softwares. You know, Spentys has its own application that makes that process much easier for AFOs and stuff like that. And then once you do those clinical modifications, the next step is then to design the device itself. I use Mesh Mixer. It's simple, it's free, it's easy. But there are a lot of platforms that, you know, can help you design those things as well.
Yeah.
And then the next step is the actual fabrication, the you know, the process of printing the device. And you know, that's how you know, get the end product. People often confuse 3D printing as a better fitting device, and I often tell people 3D scanning and 3D design can give you consistency, can give you quality, can it's a tool in your toolbox, it does not translate to a better fit. A fit is only as good as the modifications that were done on the model, whether that's a plaster model or the digital model. And so if you take a hand cast and you do a great modification on a plaster model, and then you fabricate a device the traditional way, it fits great. You'll have good patient outcomes. Of course, when you calculate all the time and the labor that you've put in the process. But it's not that if you take a scan, you'll always get a perfect fit once you do the scan. What you do with the scan is important. So understanding, how those modifications work is important.
Yeah, I want to take a few steps back because you said something important, and it was when the industry shifted almost, where design became something that you were comfortable with, when scanning became more available and the cost came down. What time frame was that?
This was around 2018, 19, somewhere around that time is when scanning technology became more accessible. So you could get a structure scanner, just attach it to your iPad and take a scan.
Yeah.
For a lot of the devices, you definitely need more higher resolution for certain type of devices, but with the structure scanner, again, even with those technologies, things have improved a lot. That's when we started seeing the practitioners being more open to the idea, because they don't have to carry this big briefcase with them with the whole white light scanning apparatus every time they have to see a patient. They can have that accessible to take a scan.
Yeah.
And so that's where we started seeing the shift. And then the second event that really helped us convince the practitioners about the adaptation of 3D technology was when they actually were able to see how the quality of the product that we were printing. I think strength has been one of the major discussions with 3D printed devices.
Indeed.
Is this strong enough? Can my patient wear it? Can my patient stand on it? And I remember the first socket that I printed took about 70 hours to print on
70
wow. hours to print on the small desktop printer. Every day I would come into the clinic and the printer was sitting on my desk, and every day in the morning I would come in and it was still printing, and I'd be like, someday it will print a socket. And 3 days later I have one socket, and I was I was very excited about that. It wasn't very strong. I could just maybe take a static trial with the patient sitting, but I didn't feel comfortable standing the patient or walking the patient on that device because it really wasn't strong enough. And but with the way technology in terms of how the printer works and the material science has improved, now I'm confident in the strength and the quality of the device that we are printing. So now when practitioners can see that they can actually use that device on a patient safely, that really shifted. And the amount of time it takes. I mean, today it takes me about an hour to print a below the knee socket on average, which going from 70 hours about 3 or 4 years ago to 1 hour for a print today, that's a significant difference in time.
Yeah, and all this is really contributing to, or the result of, the evolution of scanning, the evolution
Correct.
of modeling, the evolution of printers and materials and your slicer setting knowledge and all this that led you to this point now 7 years after getting started.
Yes.
To where your confidence is high, your process is fast and it's dialed in, and you're getting adoption across all of your clinics. And how many clinics does Bionic have today?
We currently have about 34 clinics in 9 states. Yeah.
Is digital a part of each of these clinics?
Digital is a part of most of the clinics. So when we work with so many different clinicians with different levels of experience and different level of exposure to the technologies that are available, One of the approaches that really worked well in our favor was using a hybrid approach. We couldn't have gone in and said, okay, starting tomorrow, everybody goes digital. We are not taking a cast anymore. Everybody takes a scan. It just doesn't work. We have to work with people. So we had some practitioners who were, tech savvy, wanted to jump right in. Those were the people that started right away with their scanners. So they started taking a scan. They were willing to learn. They wanted to put the effort, and they had the desire to learn about the technology. So they jumped right in. They learned how to do the modifications. We gave them access to some softwares, and they worked with our technicians. They helped design the sockets, and they wanted to be really engaged and involved in that process. And that workflow worked for them. But there were other practitioners who just didn't want to. They were interested. They wanted to have a 3D printed product. They wanted to, embrace the digital world, but they were very afraid of, going and logging onto a computer to do something like that. And we wanted to make the technology accessible to everyone, regardless of what their comfort level is. So we said, if a practitioner is comfortable taking a cast and then just sending a cast, and then our technicians can digitize that cast and then do the modifications on that. Some clinicians wanted to take a cast, but they wanted to make a plaster model because they only like the hand modification that they have done over the past 30 years, and that's exactly how they want to do it every single time, and they don't want to change that. But they don't mind how it gets fabricated at the end. And we wanted to be respectful of that skill set as well. So we allowed them to, okay, you take a cast and make a plaster model and do your modifications, and then we just design and print the socket. So really the point of this is, it's a misconception that you have to dive right in and it's all 3D or nothing. You can really have a hybrid approach based on your comfort level, based on what you're ready for, and how much time and resource you want to put into. So we use a hybrid approach. So we have some clinics where everything is digital right now. We have some clinics that still do some traditional work and some digital work, and some are still in the process of really understanding the technology.
Yeah, and it sounds like you're not, even though excuse me, even though this is a a mission. I feel like this is a mission of Bionic to have digital production and fabrication and shape capture and all this accessible, but to have it available, but it's not a requirement.
Correct.
This isn't something that even clinicians outside of Bionic in their own facilities, you're not going to have to go digital all the way in the future, but it's just going to be.
It's one of the valuable tools in your toolbox.
Exactly. Yeah. It has added value, and it has added benefits, and there's some ways that 3D technology just doesn't necessarily work best for every application.
Correct.
And I hope that you and I have that conversation over the next 4 webinars that we have, is to talk about how 3D works well, and then the reality of some applications, because it doesn't work for everything today. It's not a fix-all, solve-all tool, but it is, like you said, just a tool in the toolbox that can make things more efficient, make the shape capture and shape acquisition a little bit easier.
Yes.
And we will, we'll talk about patient cases and all that in different sections of this webinar series. But I think now, just because I really want to learn even more about the way that you guys fabricate today. So after a clinician takes a scan today, what happens right after that? Are they sending, and let's even narrow this down to a single type of device, we could go AFO, or we can go check socket, whichever you prefer.
Sure. Well, let's talk about a prosthetic socket, because that's what we do more of today. So, a practitioner takes a scan. Now, if the practitioner wants to be involved in the clinical modifications of that model, which I personally, being a practitioner myself, highly encourage, because just a scan cannot tell the complete story. Because as a clinician, when you're evaluating the patient's limb, you're really seeing what a scan can't necessarily show. You know, the quality of the residual limb, you know, how the skin is, how much you know, musculature is there. A scan can show you the shape. A scan can show you what you can see on the surface. But really, as a clinician, you have felt the limb, and you know, by experience and by your expertise, you know, how much clinical modification, how much pressure tolerant some of these areas could be. So if a clinician is interested in being involved in the clinical modifications of that model, of the scan that they just captured, then we make our software accessible to them. So either whether that's Mesh Mixer, whether that's, you know, Spentys, or whether that is the Omega software, there are plethora of options out there. We have also used the Rapid Plaster from PVA Med. They're all good softwares for different applications.
And you have, sorry to interrupt, but you have clinicians today that are using those softwares to do their own modifications.
Correct.
Okay.
Yes. So either they do their clinical modifications themselves, so they, you know, they take their scan and they do all the clinical modifications, or they, you know, give our technician a detailed set of instructions. Hey, this is what I want to be done on, you know, to my scan, and then we have some trained, you know, technicians that will follow the instructions given by the practitioner and then do the clinical modifications, you know, rectify that, and then let the practitioner know this is done, this is how it looks, you know, are we good to go? The practitioner can approve. One of the good things about the Spentys tool is you can design something, you can do the modifications, and then you can send a link to the practitioner for them to review and kind of put their comments and kind of let you know. And that's, I believe, a useful tool, because then you keep the clinician engaged with the process. And then, so once that is done, then the design and the fabrication part of it is mostly done by the technicians. Again, you know, under the guidance of the clinician. So, you know, if they want, you know, the device to be soft or flexible in a certain area, they can notify that in their work order or their process, and then we design the device. So whether that's
in like your central hub, that's where the design is mainly done.
Correct.
Most of the clinicians aren't designing today.
Correct.
Okay.
Unless, like I said, there are some clinicians that are into it, that want to be involved in that process as well, and you know, we certainly engage them and allow them to be a part of the design process if they choose to be. Most of them are not. You know, they maybe want to be involved with the clinical modification, but then the design and printing, you know, they're like, well, you know, this is what I want. Give it to me, and then our technicians can then design that. And
yeah. And how many technicians do you have designing today and modifying?
We have about, so we have central fabrication facilities in different places in the country. One of our main labs is in Maryville, Indiana, in the Chicagoland area, which is our 3D printing hub as well. So we have about 7 or 8 technicians there right now, and rapidly growing. We started out with a 5,000 square feet lab space, and now we're at about 25,000 square feet of lab space.
I've seen it. It's impressive.
So,
yeah.
So, you know, we have 2 technicians that are completely on the digital side of things, and then we have others who do the traditional fabrication as well today. And then, you know, they design and print it there. Or if it is something, you know, we are 3D printing something using MGF technology. So, you know, we use Spentys and, you know, depending on what we are printing. So either we design it and then we, you know, print it in-house if it's FDM technology. But if it's something we are designing on a Spentys platform and we want an MJF printed device, which is the appropriate application for certain type of devices, then we, you know, send the order to you, and then you guys print it and send it to us for our patients.
Okay. And when you're shipping devices like that prosthetic socket to the clinics to be fit, are they completely finished? Like you have done the post-processing on the devices, you've done, what does that look like?
Well, so post-processing on FDM technology is much lesser as compared to other technologies that are out there. So depending on the type of printer you use and the method you use for printing, sometimes the post-processing could just be smoothing out the edges, or sometimes post-processing could be, well, you printed it in a vase mode, so you didn't really print with the trim lines, and then all you have to do is just, once it's printed, you just cut and trim and just polish the edges. So that post-processing is done in the lab. So what the clinician really gets is the end product, ready to be fit to the patient.
Yeah. So they scan, they choose to modify, or somebody else modifies.
Correct.
They choose to design, or somebody else designs.
Correct.
But then printing, that's
Yes.
completely taken care
Yes.
of because you have the expert. I mean, to learn all the things that you learned over 7 years, you're really speeding up that process so that the practitioners don't have to have that such learning curve.
Correct.
Which I think is very valuable because from what a lot of people tell me, clinicians are really good at seeing patients
Yes.
and taking care of the patient's needs, and that is important.
Right.
And to be able to still have access to some of these fabrication techniques and things like that is really important too. But to lean into your expertise the CFAB's expertise there for everything is quite nice.
Yeah. I mean, that's the whole goal. How do we make the process more efficient, where the clinician can spend more and more time with the patient, taking care of the patient, and make the processes of scanning, fabrication, and all of that, which traditionally used to take up a lot of time of the clinician and the technician as well. How do we make the process efficient where you can still get a quality product for your patient in the most efficient manner possible, whether that's in terms of cost, whether that's in terms of labor, whether that's in terms of time, and still focus on patient outcomes rather than the whole process. So
the cost, the time, and the labor. What is the reality here? Is there time savings? Is there cost savings? Is this even what's most important? Tell me about your traditional versus your digital let's just use the specific application of a 3D printed prosthetic check socket.
Sure. Well, it's very, very important, as everybody who runs or manages an O&P practice knows, that the cost of doing business has been going up considerably in the past few years. The reimbursements really not so much. And the documentation requirements today for O&P devices, the practitioner has to spend so much time just documenting and documenting and documenting. And really all of that is taking the focus away from what's most important, which is taking care of the patient and focusing on patient outcomes. And really what we need to think about is how are we going to allow the practitioners to spend more time with the patient and less time on the computer and all of the other processes. And one of the things that we have worked on is the digital workflow, because that really has an impact in the time and the labor and the cost even. In terms of time, I mean, if you just take a timeline of traditional fabrication, I mean, how do I get to a point where I have to try a diagnostic test socket on a patient? The patient comes in, I put the liner on, I take a hand cast. That's maybe 15 minutes, 15 to 20 minutes with all the preparations involved. And then you fill the plastic cast, you make a positive model, another 20, 25 minutes, 30 minutes, depending on how good your technician is. Sometimes it fails and then you have to refill it. We have all seen plaster disasters in the lab. And then, and then you have to wait for that plaster model to be, set enough where you can then, then you have to strip the cast off of the model, and then you have to, the clinician or the technician then has to find the time to actually physically be there, and then, do those modifications. And then you need all of this equipment. If you're making a test socket, you need plastic sheets, you need the oven, and then you turn the oven on, you put the plastic sheet in, and then you bubble form over that. Take easily another half an hour, 45 minutes for that process. And when that's done, then then you have to break the mold from what you just bubble formed, and then you have to cut and trim and polish. Add another half an hour, 40 minutes to it. So and then you're ready for a trial. So if you put all of it together, 2 hours, 3 hours, I mean, at the very least, and you have to be involved physically with that process, whether that's you or your technician. It's not automated, right? And the whole process is manual. Now let's look at the same scenario in a digital workflow. Patient comes in, you put the liner on, you pull your phone out, or you take your iPad and you just scan. How much time does it take to scan a limb? 2 minutes?
Yeah,
I mean,
if
that. I mean, if an experienced clinician can take it in 30 seconds.
Yeah.
But let's say worst case scenario, 3 minutes to take a scan. Another 5-10 minutes maybe to do all the clinical modifications. Literally right there, you have the scan, you can just do your modifications there, design it. Another 5-10 minutes depending on the application you use. If you're using an application like Spentys, it's all just go to the next step, and then you draw your trim lines, it's ready, you hit print. So so from scanning to modifying to designing to hitting print, it's 15 minutes, maybe 20 minutes.
Yeah.
And then while it's printing, you can go see your next patient, and an hour later, hour and a half later, the socket's ready. And during that time when the printer was printing, it's not taking up your time. Then you can do your documentation, or you can go to your next patient while it's doing that. And then some post-processing, maybe 15-20 minutes of post-processing on that. How much time and labor did that save you?
Yeah.
So that's something to think about. It's significant. And even if you don't have your printer in-house, even if you are using a different model, even if you're maybe fabricating it through Spentys, from taking a cast to shipping the cast somewhere where it gets fabricated, versus taking a scan and just hitting send, and then you get to be a part of that modification process or design process, because you can digitally communicate, and then to get that device, it's very cost efficient if it's implemented the correct way.
Yeah, and I mean, a lot of what you're sharing now compared to what was available 7 years ago, it just wasn't possible.
No.
Absolutely not possible.
No. The material science wasn't there, the printers weren't there, the technology just wasn't there.
Yeah.
But it's come a long way in the past few years, and I can only imagine where it will be in the next 2 or 3 years. So really, this is a great time to jump into the digital workflow, because things are only going to get better.
Yeah, totally agree. Well, that is all that we have for today. And it has been a pleasure to talk with you, to go through your journey from a 70-hour print to today. You have access to 3D technology over 34 clinics today. That's significant. And I hope that you guys took something away here. There is plenty to talk about, and there's plenty more to talk about. So this is going to be a series over the next 4 weeks. Well, this is week 1, so 3 more weeks you're going to have the opportunity to dive deep into the nuts and bolts of 3D printing, the actual implementation and the integration of these tools and what that looks like on a consistent basis. And then you're going to join us at AOPA, to where we talk about the future of 3D technology. That wonderful idea of like 2 to 3 years down the road. Like, we're now at a point to where things are moving fast, and it's going to be fun to talk about. So I hope that you join us. over these webinar series. Again, my name is Brian Kraft and I'm joined by
Sagar Shetty with Bionic Prosthetics and Orthotics.
And it was a pleasure to speak with you today and be with you. We'll see you soon.